Alright guys, I'm not fully awake yet, so I apologize for that. As you can see what time it is in the morning, it's 4 a.m. In 2 minutes my water will be ready. 5 minutes after that my tea will be steeped, and you might notice a nice little, little pep after I have my consumption of um, caffeine. All right. So now, first of all, we gotta fix this issue. Okay. So from the time that I did the last video and now several hours have gone past, we still have a blocking port with our topology, and we are rotational and we are not having a broadcast storm or no Mac flapping. So we have determined that switch 2 was a failure. And if I was going to take a guess, okay, I am assuming that FAO3 port, okay, because every physical port on a switch has, I think, an average of 4 queues, hardware queues, that is, and that's back in the 3550 era. So today, who knows, okay? There might be more, it might be the same. It doesn't really matter. Those different queues could be used for different types of traffic, for whatever. The bottom line is, I doubt if this was a software issue, meaning that, now of course in the field, first thing I would like to do will be upgrade to iOS and see if that fixes my issue. Okay, from your perspective, this troubleshooting incident, because if we go back to our channel here, come on, close. All right, hang on for 1 second. I'll be right back. Okay, and now let's set a timer for 5 minutes for our tea steeping, and then I'm gonna add my milk, and then I'll be able to get some caffeine in me. So now, as I'm looking at the videos, 1, 2, 3, 4, 5. We have 5 videos dealing with this issue. Okay, now if we were going to do the time, okay, we'll call this one 2 hours. Actually, these two will be 2 hours, 2.5, 3 hours, and 3 hours and 15 minutes. Okay, it took me to figure out what was going on. Now, of course, this is not 3.5 hours or 3 hours and 10 minutes, whatever, of consecutive troubleshooting. Okay, all right, and believe it or not, okay, that could be a plus or a hindrance. Okay, meaning I could do the shortness of time because the time could be shorter due to the fact that I am in a groove or in a zone after a couple hours and kicking butt, or I could be kind of getting like sporadic, running on ideas and just kind of like and forgetting where I was at, and forgetting what happened when I did this, and having to go back and re-troubleshoot certain things and start taking notes so I don't have to redo it again, things like that. Okay, but regardless, okay, how you perceived this issue, this was a cakewalk. I mean, there's no way to say this. Now, if I was starting my, if this was 15 years prior, okay, all right, 3.5 hours would have been weeks and weeks. And don't get it twisted, okay? There will be scenarios and situations where weeks have gone by before you can figure out this issue, Okay. Now I'm not talking about this issue, but any issue. Okay. Guys, that's that is paying your dues. Okay. That is learning what it is to troubleshoot, and you just get better over time. Okay, so from your perspective, 3 hours of video watching is horrendous. For me, it was a cakewalk. Okay, and as we got back to the end, as I replaced the fourth switch, okay, finding out that it was the second switch was obvious. Okay, because we've already pinpointed between two. Now, because of why this was, because you have to understand how I troubleshoot. Okay? All right? I don't look at network devices as a whole. Every one is a separate entity. Okay? When a packet gets here and a packet needs to go out, okay, if the connecting switch does not receive that packet, well, either that switch that's receiving the packet is bad or the one that's sending it is bad. Okay? That's how because I look at every device as a separate entity in the large scheme of things. When you look at these devices as a whole, entity, having 30 devices and a whole entity, that makes it makes you process things a little differently. Okay, all right, and now keep in mind. Okay, I'm not saying that you are incapable of doing that, thinking of all of them as a single entity. I'm telling you, when I used to do that, okay, that was a crutch for me. Okay, not a crutch, a hindrance for me, until I started looking at it from a device by device basis, and I started doing this once I started looking at debug output. Okay, nonetheless, all right. Let us do some spanning tree situations here. Now, with spanning tree, notice that I don't have 3 switches. Okay, because when I have 3 switches, all right, and we're going to take 3. Go on. All right, when I have 3, okay, let's say switch 1 is the root. Okay, we already know that these 2 are designated and forwarding ports because the root bridge has all their ports forwarded. Okay, we know that. Now, okay, that means the root ports, okay, are obvious. All right, this is going to be a root port. This is going to be a root port. So the only thing that's left is a connection between 2 and 3. One of them is going to be blocking. It gives you a false concept of understanding how transparency really works from its election. Okay, all right. Now, hold on for a second. I'm pouring my milk. Now, here's the reality. Once you add the 4th switch, there is no. You have 2 switches left in determining which one's going to be the blocking port, and that's important because it's not just one link, okay, that we're worrying about. All right, between 3 switches, it's actually okay. We got to determine which is going to be, which means we need another. We are going to use another layer of elections. Give me a second. Oh my god, that's good. Okay. So if we look at this, let me bring up my pad here. All right, and now let's take a look and find out who is going to be the root port. Okay, now I'm going to make switch 1 the root port. And what happened to my link? I just like deleted, huh? Okay, fine. All right, so here. Oh no, it's there. My bad. Okay. So now, what we're going to do is we're going to force root 1, switch 1 to be the root. Okay? Alright? And this is why this is bad. I got this, and I'm not going to be able to fix this. It's a lack of space that I have. I can't use the drawing pad and the keyboard at the same time. But that's going to change once I get my new desk. Alright, so first of all, do show spanning tree. Okay. This is there it is. Man, I was looking hard for that port, for that root port. Okay, so that's GO1. So that means switch 2 is probably the root bridge here, since it's a cost of root 19. So if we look at this data, okay, all right, and I guess we'll start there. As we're doing a show spanning tree, first of all, we're going to have the root ID, okay, and every spanning tree command, as we're looking at show spanning tree on every device, we're going to have the information of the root bridge, okay, all right, which it calls it's the root ID, okay. All right, you're going to have the MAC address of that root ID and the cost of 19. Now, if this is 19 and this is 19, what does that tell you? That tells you that one of these links are going to be the root port, okay? Since the cost is 19, unless 4 and other hops down the road equals up to 19 in some aspects, okay? Remember, I'm assuming, okay? But I kind of know, right? So, because in effect, we did previous configurations that made switch to the root bridge anyway. But nonetheless, all right. So, it's going to tell me the cost to the root bridge, okay? All right. It's going to give me my hello timers, my max age, and my forwarding delay, okay? All right. The forwarding delay is going to be the listening and learning. Okay. So now. Here, this bridge ID information is the local switch that I'm logged into doing the show spanning tree configs. Okay, as you remember before, okay, I kept looking at this MAC address, which I don't know if you noticed it or not, and still looking at this one when I was putting in the MAC addresses in these spots. Okay, and when they both came out with the same MAC address, I'm like, what the hell's going on? And I realized the output that I was reading the wrong output. Okay, so now, which happens all the time. So now I'm going to go over here. Let's say no spanning tree VLAN priority. Okay, I'm just saying no. I'm VLAN 1. I'm disabling this command. Okay, so now let's take a look at our. Okay. Root bridge is still going to root 2. Now, remember, hold on, that shouldn't make any sense because root 4 should be the root bridge. This bridge is a root. Much better. Okay, so now, why was it reporting 19 at first? With the last command, and then 38, and that would probably be most likely our forwarding delay. Okay, the time it takes for the spanning tree to do its calculation. Okay, all right. Now, stop right there. I might say that, but could I be wrong? Absolutely right. Could Cisco documentation be wrong? Absolutely right. Okay, guys, it is too much to remember. And to remember it all and to be accurate all the time. Okay? So, if you are expecting to be the man and always the smartest guy in the room, hey, hats off to you. I got more important things to do. Okay? And the most important thing that I normally say, and I say most of the time in my life, is 2 things. I don't know, and oops, I forgot, or my bad, I was wrong. Okay? All right? It's never going to change. For the next 20 years, I'm going to be saying the same thing. I don't care. I got more important things to be embarrassed about. Okay, and I'm telling you, you're going to run across people who are like that, and those people are chaotic. Okay, because they're always trying to create an image instead of doing and having the skill set that sets them apart. Okay. All right. Now we all go through this. All right, especially in the beginning when we're learning. We want other people to teach us. Okay, we want other people to mentor us. We want to learn. Okay. All right. I do the things that I do because I never got that. All right, and I was trying to obtain it heavily. So I became the change in the world that I wanted to see. So that's why I became who I was, and I never looked back. All right. So okay, so part of this forwarding delay, okay, uh, you know, do your own research. All right, so we definitely know the forwarding delays on the ports, but this is talking about the bridge. Okay, now maybe we could do this. All right, let's check this out. Let's change. We can prove this by going on to the root bridge, which is 4 at the moment. Okay. All right, so we're going to actually say spanning tree VLAN 1. Okay, so we're going to say 4 time. Okay, 4 time, we're going to say 4 seconds. Okay, now, once we do that, okay, it's going to send out a beep to you and update. Look at that. Okay, meaning that this on this particular bridge, the forwarding delays of its ports are going to be 4 seconds long. Okay, not 15. Okay, meaning that you're going to have 4 seconds for the forwarding delay. I mean, for the listening, and 4 seconds for the learning. That's 8 seconds. Okay, all right. Well, the other one was 15 for each. Okay, so now we proved that. Okay. Rule number 2, guys. Rule number 2. Whatever you learn from me or any other instructor or Cisco themselves, okay, meaning you're reading their documentation, you are not to trust that information. You are going to prove that information correct by the equipment itself. And I'm not talking about emulators, and I'm not talking about software crap. Okay? And yes, I call it crap. Alright? I'm talking about the real hardware and the real iOS telling you, okay, what's what by its behavior. Now, you got a bad switch like we had before, you know, c'est la vie. But every time you have those things in those situations, okay, guys, it just makes you stronger. So, we are going to make switch 1 the root bridge, okay? But before we do that, we are going to take this drawing pad and we are going to determine what our port should look like. Once you really truly understand spanning tree, you will be able to do this on paper with 20 switches and hook up 20 switches and find out if you're accurate with all the port states. Okay? Alright? It's just the way it is. Okay, can I remember the name of this damn thing? Probably not. So let's because I want to say sketch again, and I'm always wrong with that. Screen, screen. Get it through your thick head. All right, so now, okay, so being self-aware of the things that you do, this is going to be one of those issues like screen. Okay, I'm going to have to. If this gets to the point where I can't find it on a regular basis, this is going to be a problem for me finding this application. I can go down and go through it, all the applications through the start menu, okay? But if I start adding more things on there and I can't find it and it gets drowned out, I'm gonna have to take a sticky note, okay, and put it on my desk with the application written out, okay? Or put it in a notebook or put it in Notepad. All right, because I know how I am. That's that self awareness is. Okay, and over time, what you are learning is self awareness. Okay, how do I change the color? Have I not learned that yet? Oops. Okay, that's not. Oh, here we go. Here we go. Okay. Okay, so this is the root. All right. So obviously, these are going to be designated ports. Designated ports right off the bat. Okay. And they're going to be forwarding right off the bat. Okay. Because it's the root bridge. All the ports that are connected to other switches will always be forward designated ports. Okay. Now remember, your designated port is going to be your role. Your status is going to be your forwarding. Okay? Makes sense. Now, remember, switch 1 is not the root bridge yet. Okay? So we're going to make those changes here in a second. Now, okay? This is going to be based on the priority being 0, which will beat all the other default priorities, regardless who is the lowest MAC address in the scheme of our domain. All right. Now, since all these are forwarding, okay. Now let's go find the root port. Okay. From switch 2's perspective, okay. And actually, let's do this. Okay. All these links are 19. The cost of 19. Okay. So there is no tiebreaker there with the cost because they're all the same. All right. I'm sorry. There is a tiebreaker there because they're all the same. There is no. I'm gonna leave it at that. That's the best way to say it. So no, I don't want to quit. And now I'm gonna go to switch 2. This is a cost of 19. This is 19 plus 19 plus 19. Okay, so this is going to be my root port. Switch 3, this is 19. 19 plus 19 plus 19. This is going to be my root port. Okay, and then 4, all right, 19, 19, 19, 19. Now we need a tiebreaker. Okay, now what makes this a tiebreaker? It should be, okay, it should be whoever I am paired with that has the lowest MAC address or the lowest bid ID. Okay, so 0000114B. Okay, B is what? 10, 11. All right, so this should be the root port. Now, it is now between these two. Okay, our port priorities are not going to be utilized because we do not have 2 links. If we had 2 links, it would be a tiebreaker and we need the port priority to be a tiebreaker, but that is not the case here. Okay, so now between here, we got to decide who is going to be designated. Okay, so since this has the lowest, okay, since this has the lowest MAC address or bid number, okay, it should be designated, and this will be the blocking port. Okay, sorry I put them in the same colors, but still. All right, so now let's go find out if we are correct. All right, because if we're correct, we understand spanning tree. All right, so now, okay, so let's move this drawing pad. Okay, so let us clear this off. let's go ahead and copy this command with the. Come on. All right, my mouse is acting a lot better too because some a mouse setting that I just found in Windows. Okay, so now we are going to actually we gotta do this again. So do no, spanning tree, VLAN 1, priority 0. Okay, this bridges the root. Let's do this again, again, and again. Okay, so now let's bring back our data and let's take a look at 4. Is FAO1 forwarding? No, it's blocking. Let's do it again. Okay, so now let's go back and take a look at our other outputs. All right, notice that oh, this is still listening. Okay, much better. Okay, so we're designated, forward and forward. Switch to, okay. And FAO1 is the root port. FAO3 is designated, right? Okay. Switch 3, FAO2 is the root port. And this is designated. So here is, oh, wait a minute. Okay, yeah, all right, so we got that right. Okay, so that means the election between these two, we are confused. So now, I'm confused. Okay, so now we're going to actually go back here and find out what is Cisco spanning tree election process. Okay, root bridge election. Notice, guys, you want to learn, go to Cisco documentation. Now this says the learning network. Is this Cisco documentation? No, that's a forum. I don't do those. Okay, so that's a... Okay. Here we go. Okay, Cisco.com, spanning tree, and multiple spanning tree. Okay, so this is a page, and what we're going to look for is election of the root bridge. Okay. Blocking state. Okay, that's not what I'm looking for. Listening, learning. Okay, why are we going through this? Port roles, okay. Rapid convergence, not looking for that. Okay, so let's now we're going to do it this way because I'm not getting the information I want. I'm getting too much. All right. Cisco docs. Spanning tree. Wow, they changed their stuff a lot. Alright, let's make this big here. Okay. View all documents of this type. Wow. Okay, so I don't have election in there. Okay, so let's do it the simple way. So Cisco spanning tree election tie breaker. Lowest path of the same. The switch with the lower IB is preferred. Okay. Alright. If there's a tie in priority, the lowest MAC address it is not expected to see explanatory elections. Yeah, that's not really what I want. Okay, so to me this should work. Okay, so we have B700 9508. This is a report. This is the report. (001B). I really believe that this is going to be backwards, but it's not. Okay, I was not expecting that behavior. I'm going to have to do more research on that and probably come back with a different video because that's not my understanding of it, and I have to find the right documentation of it, which is probably going to be one of my books, probably my CCNP book, as we're going through Spanetry, or even a CCNA book. As a matter of fact, you know what? Let me see if I can solve that right now. Let me go ahead and pause this. I found it in my MSN book. Okay. Let me go back to it. Okay. Only one of the links on a segment should forward traffic to and from that segment. They're talking about the links between the switches. All right, the one that is selected as a designated port. Okay, switches chooses a designated port based on the lowest cumulative route path cost to the bridge. That's why switch 3 wins the designated port. Okay, so I was wrong in that aspect. Okay, won't be the last time. But still, all right, that's why, guys, you don't throw your books away. Okay, these books are Bibles. All right, and they're references. Okay, and hey, That's why. So yeah. So we were wrong here. Okay. So now we know why this one is blocking, because it has a root cause path to as of 38, where this one has um, uh, 19. Now, as I'm reading that, I recall teaching this the correct way back in the day. But hey, I'm old now. Okay? Now, it ain't oldness that actually causes you to do this. Alright? It gets to the point where you have learned, forgotten more things than the average person has learned. Okay? Because of the extensive studying and all those things in your brain. Guys, that's why we go back to documentation. Okay? I'm giving you this image because I want you to realize that you don't walk in and be Mr. Know-It-All. And just because you're CCIE doesn't mean you know it all. Every CCIE knows what I'm talking about, okay? Because they have a common reference, all right? They've forgotten more things than the average person have learned that they deal with on a regular basis. And, they just forget stuff, okay? All right? It's just the way it is. All right, and talking to another CCIE, if he's watching this, he'd be like, "Yeah, shit, I do that shit all the time." Okay, so that's why we were wrong. I was wrong there. Okay, so now I should be able to put on this board 20 switches, hook those 20 switches up correctly, and be able to write out. All right, every state and role that port should be, and I should be accurate. Okay? 3 switches, forget about it. That just, it's not a good way to learn span tree, okay? Alright, so now that we've gone through the election, okay, alright, let's find out if I go on to this particular port here, okay, and actually, you know what? We're not going to talk about that because that's out of the scope of doing this lab. This lab was really just to give you an idea of what to do on how to lab span tree and what to do. Okay, and it's been a great experience. We got trouble after trouble after trouble after trouble, and we finally got to this aspect. Okay, showing you how to put out all the switches, the links, the number of the switch ports, who's going to be the root bridge, the bid ID. This is something you're going to write out on paper or draw in Visio every time you do a lab. Okay, religiously every time. All right. If you're not drawing your own labs, you're missing out on a lot of stuff, guys. Okay, I know there's lab books out there. Okay, I don't use them. I only use my own labs. Okay, even CCIE level labs, guys. I've only built my own. Okay, trust me. It's a unspoken skill set that you learn things that you're not taught. Okay, so in that incident, this is the basics of spanning tree. We changed the root bridge by changing the priority. Obviously, we can't change the MAC address, so your priority, that's why your bridge ID is the priority and plus the MAC address. Okay, but we can manipulate that by making changes. Okay, we went through our roles and our elections. Okay, we got one part right. We found out the information on why it was wrong and why it chose number 3. And now, being re-solidified, that's going to give me a length of time where before I forget it again. All right, welcome to networking, guys. Hey, thanks for watching. Be strong, be determined, be Cisco. I'll see you guys in the next one.